Let's understand what do we mean by model in the context of artificial intelligence in this video. When we say model, we are talking about a mathematical structure or a program that takes some data and makes prediction or decision on that particular data. You can think of this as a brain. So you provide some input and it does some processing and it gives you some output. How is it different from normal computer program? The difference is, if you're writing a normal computer program to make prediction or decision, you'll be explicitly specifying what exact steps the program needs to take using this data to come up with either prediction or decision. But when we are talking about artificial intelligence model, we will not specify any explicit steps. What we will do instead is, we will have something called data set that will have our input data and it will also have expected outcome. So that could be our expected prediction or decision. We call the data as a labeled data set. Then we do something called training. In the training, what we will do is we will pass in the data as input and we will specify to the model that this is the expected prediction or decision. So then what this model will do is, using that input data, it will see what it needs to do internally to provide this particular decision or prediction. And to achieve that, the model will adjust its internal parameters. So this whole process is called training. So we basically provide data to our model to adjust its own parameters to provide the expected prediction or decision. So that is what an artificial intelligence model is, and this is how it is different from a traditional computer program. So basically what this model does is, it learns the pattern in the data and it encodes that pattern somehow within this mathematical structure. So when it sees a new data, it will be able to make prediction or decision based on the pattern that it has previously learned. Okay, so that is what an artificial intelligence model is. For example, if you are taking spam filter, if we provide bunch of emails that are combinations of spam and not spam, with a label saying that this particular email is a spam email and this particular email is not a spam email, and if we provide that as an input with the expected value as either spam or not spam, then the model is going to adjust its parameter to consistently identify spams and not spam emails correctly, right? So once the training has completed, if we provide a new email that it has not seen previously, then it will be able to identify whether that particular email is a spam email or not based on the pattern that it had learned from the previous examples that we have provided. So that is how the artificial intelligence models work. And if we take image recognition as another example, we'll be providing different pictures. For example, we'll be providing dog and cat pictures. And based on that, it will kind of recognize the pattern for dog as well as cat. And when you provide a new image, which is either cat or dog, it should be able to identify whether the input image is cat or dog. Okay, so that is the basic idea behind artificial intelligence models. Now, let's move on to a specific type of artificial intelligence model called neural network. Neural network is basically a model inspired by human brain. It tries to mimic what human brain does, but not exactly, but that is the basic idea of neural network. If you see here, we have this example here. So this is a typical neural network. And in here, we have something called input layer. So the first layer is always called input layer and the last layer is called output layer. And we have some hidden layers in between. So these circles are called neurons. You can think of these as intelligent unit. It will be able to make some decision based on the input that it receives. And these are neurons in the input layer and these are the neurons in the hidden layers. If you see here, the input layer's neuron is connected to all the neurons in the first hidden layer and the connection continues until we have the output layer here, which is the output neuron. And if you see these connections are weighted, as in the value that goes from this neuron to this neuron can be controlled by something called weights. Okay, so if the weight is 0, then the output from this particular neuron will have no effect on this neuron because the output of this neuron is completely nullified by weight 0. So this neuron will not receive any input from this particular input neuron. On the other hand, if the weight is 1, for example, then the output of this particular neuron is 100% going to be taken into consideration for making decision on this particular neuron. Okay, so just to go back, we have these layers. We have input layer, hidden layer, and we also have output layer, and each of the layers have a bunch of neurons, and output from the previous layer's neuron are connected as an input to the next layer's neuron, and those connections are weighted, as in we will be able to control how much the output of one neuron is going to influence the neuron in the next layer using those weights. And within each of these neurons, we have something called activation function. So you can think of activation function as something like, if the value coming in goes above a certain threshold, then it will produce some output. If it has not reached that level, then it will not produce any output, for example. So activation function is something that is going to decide when this particular neuron is going to emit any output. Okay, that is what this activation function is. So at a high level, when you pass in an input here, for example, then you can actually consider the hidden layer as some sort of processing unit. This is going to detect the patterns of the input data, and in the output layer, we are going to provide the output. So if you take the previous example that we have seen, where we are trying to identify whether a given image is a cat or a dog, then we will pass the input image with its pixel data to this input layer, and this hidden layer is going to recognize the pattern in that particular image, and it will identify whether this is a dog or cat. And in the output layer, we will get a probabilistic result indicating whether this is going to be cat or dog. Okay, so that is what this neural network is at a very, very high level. And I talked about this weights earlier, right? So you can think of these weights as knobs that can be adjusted during the training process. So when you are training this neural network, for example, to identify cat versus dog, then we will have labeled data set, and that data set will have a bunch of cat images and dog images with a label indicating whether this is a cat or dog. Then during training, what will happen is, let's say for example, we are feeding in a cat image and we expect that output to be cat. Then the neural network is going to tune its weights of these connections to produce cat as output. And then when we are actually providing dog input picture during our training, then the neural network is going to adjust its weights again to predict this dog image as dog correctly. So that is how these weights are going to be adjusted during training process. So it will kind of recognize the pattern in general. So it will be able to easily identify both dogs as well as cats. And this example is a very simple neural network. But in practice, we will have many hidden layers. So the more number of layers we have, the more complex problems that we will be able to solve. And this is why neural networks are sometimes referred to as deep learning, because the deeper the layers are, the more complex problems we'll be able to solve. Okay, so this is not a deep dive session on neural network. I just want to provide some high level information in terms of what is a model and what is a neural network model. Okay, so now we understood what neural network is. Let's move on to another concept called transformers. So transformer is a type of neural network. So this was introduced by Google in a paper called Attention is All You Need. And this paper introduced this transformer architecture. And again, this is a type of neural network architecture. Why this transformer matters? What is good about this transformer architecture? Well, transformer handles sequential data for natural language processing. So before the introduction of transformer, processing sequential data is very difficult. We don't have any good way to do that. But with the introduction of transformers, we are able to process sequential data much more efficiently, and that is what we need for natural language processing. So this includes tasks like translations from one language to another language and summarization of text as well as text generation. For example, you provide a phrase, you ask the model to complete the rest of the phrase. So that is text generation, and that is also made possible by this transformer based models. And like I said previously, this transformer is a big moment in natural language processing. With this transformers, models understand languages more deeply and efficiently. So previous to transformers, the language understanding of the models are very little. But with the transformers, we have exponentially improved that. And this led to a lot of popular models. One of them is GPT. So this is the model that powers ChatGPT. GPT means generative pre-trained transformer. As the name implies, this is transformer based model. And GPT is actually a general purpose model. It will be able to do many different things for you. That includes translation, summarization, text generation, and all those things. And we have other transformer based models as well. So one of them is BERT. This is from Google. And this model is very good at filling the missing word. So if you have a paragraph and you have a word missing, and this BERT model will be able to fill that word for you. And T5 is another model from Google. Again, this model is also based on transformer. And this model is very good at translation. So if you want to translate something from one language to another language, then T5 and all the models built based on T5 are really good for that. Okay. So just to recap, we have seen what is a model at a very, very high level. Then we looked at a type of model called neural network. Then we also looked at a type of a neural network model called transformer. And we also had a brief look at why this transformer model matters and what is the significance of it. Okay, so that is all I wanted to cover in this video. I hope this is useful. Thank you.